Alright, welcome back. So last time you watched, you saw how the derivative of e to the x is just e to the x. So we're going to use this new property to determine dy dx if y is in fact equal to e to the power of x plus x squared. Okay? So if y is equal to e to the power of x plus x squared, this problem can be a little intimidating because this piece right here this looks scary. And I don't want scary looking things in my problem. So I'm going to let u equal x plus x squared. Now this is a common calculus trick to make problems easier. We're going to work out an easier version of them and then work it out from there. So if that's true, then y is then equal to e to the u. Now remember when we learned the chain rule, we learned that dy dx is equal to dy divided by du times du divided by dx. Okay, so what we're going to do now is we're going to take, so if I want my answer to be dy dx, I just need to find those two pieces and multiply them together. So dy du, so y is equal to e to the u. So dy du is going to be equal to e to the u, because the derivative of e to the u is just e to the u. It's itself. So this piece is going to go right here. And then u was equal to x plus x squared. So du dx is going to be 1 plus 2x. And this piece is going to go right here. So our final answer is going to be dy dx is equal to e to the u times 1 plus 2x. And we're almost done, except we're not supposed to have any u's in our answer. So we're going to substitute the u back in for x plus x squared. So our answer becomes e to the power of x plus x squared times 1 plus 2x. Again, it's the derivative using the chain rule. I'm going to show you another way to take the same derivative. So that's the Leibniz way, using the chain rule. I'm going to show you the Newtonian way. So if we have y is equal to e to the power of x plus x squared, remember that the derivative of e to the x is just itself. So when we take dy dx, it's the whole function. Okay, so it's the whole function, e to the power of x plus x squared times this stuff right here. So again, it's e to the power of whatever was there times the stuff right here. So times that x plus x squared. So it's times the stuff when you take the derivative of it. That's the chain rule, right? It's the derivative of the stuff. So then your answer is dy dx equals e to the power of x plus x squared times 1 plus 2x. And you end up with the same answer. I like doing the Newtonian way, but it works either way. Alright, let's do one that you're going to try on your own right now. So I want you to determine dy dx if y is equal to e to the power of the cube root of x. So I'm going to show you both ways of doing it, one way and then the other way. Let's do it. So y is equal to e to the cube root of x. So then I'm going to let y equal e to the u, and I'm going to let u equal the cube root of x. So then dy dx is equal to dy du times du over dx. Should probably do that one in green. Okay, so dy du is just e to the u, right? If y is e to the u, the derivative of e to the u is simply just e to the u again. All right. So, too loud. So if I were to take the derivative of this function, u equals the cube root of x. And I'm going to write this to the power like that. So I'm going to write it as power notation instead. Then du dx is simply just 1/3 x to the negative 2/3, which is what to say 1 over 3 x squared and the cube root. So the cube root of x squared. Now we just plug in everything. So then dy dx is equal to dy du, which is e to the u, times du dx, which is 1 over 3 times the cube root of x squared. And now we need to get rid of our u in the answer. So then it's dy dx is equal to, again, u was equal to the cube root of x. So it's e to the power of the cube root of x over 3 times the cube root of x squared. That's it. That's using the Leibniz way. That's one way to do it. Now I'm going to show you the other way. So this one, this is way 1. Way 2, when I have y is equal to e to the cube root of x. So let's take the derivative of that, and we get y prime is equal to e to the cube root of x. It literally just stays the same. You take the e, you take the same thing, and then you take the derivative of the stuff in the power. So I'm going to take the derivative of that. So this becomes y prime is equal to e to the cube root of x times x to the 1/3, and then a power for the derivative. And I know that the derivative of that from the last example we just did is e to the cube root of x times 1/3 x to the negative 2/3. So now I'm going to write that all as one nice big answer. Y prime is equal to e the cube root of x divided by 3 times the cube root of x squared. And you see you get the same answer. Alright, we're going to do 2 more problems. Here we go. So we're going to differentiate y equals x times e to the x minus e to the x. Now, this is going to involve a couple steps because we need to combine some rules. Notice that right here there's a product. So let's go ahead, let's take the derivative. Y prime is equal to, now here you got to use the product rule. So I'm going to get the derivative of the first, which is 1, times e to the x, plus x times the derivative of e to the x, which is just e to the x, minus e to the x. So again, this is the product rule. Okay, so in the green, we need to think product rule. Alright, now we just do some simplifying. We get y prime is equal to e to the x plus x e to the x minus e to the x. Well, lucky for us, these are going to cancel. And so you get the derivative is x e to the x. And that's it. Alright, now I want you to try one on your own. So now I want you to try to differentiate x squared times e to the negative x. So go ahead and try that out right now. Alright, good job. Now let's just check to make sure we got the same answer. So right here you notice that we have a product. So we're going to need to use that product rule. So you get y prime is equal to the derivative of the first, which is 2x, times e to the negative x, plus the first times the derivative of the second. So I'm going to go ahead and I'm going to take a step to write just the derivative of the second. So y prime is equal to 2x e to the negative x plus x squared. Now the derivative of e to the negative x is just going to be e to the negative x times the derivative of negative x, the derivative of the exponent. So this is y prime is equal to 2x over e to the x plus x squared over e to the x times a negative 1. So we get y prime is equal to 2x minus x squared over e to the x. And I'm going to factor out what I can because sometimes it'll help us. So you get y prime is going to be x times 2 minus x divided by e to the x. That is the derivative.